Hi everyone, we will find the version space by using the candidate elimination algorithm, which will give you non-minimal and non-maximal consistent hypothesis by computing minimal generalization and minimal specialization of given hypothesis space H for the given dataset, weather dataset given here, which is having the 4 samples, and the target concept is also given here. And as per the algorithm initially, which is specifying the most specific hypothesis with all null constraints for all the 6 attributes, and more general hypothesis g0 with all general constraints. Now second step is we have to check given example is positive or negative. So the example is given here. The target concept of the example 1 is yes, so this example D is positive example. If it is the positive example, then we have to start with the general constraint, general boundary. So in the general boundary here we are having the g0, so we have to check the this constraint is accepting the attribute value of given example or not. So this general constraint is accepting the sunny or not. Yes, it is accepting, then it is a true. And logically, and here it is accepting by the second constraint or not. Yes, it is accepting, true. Then third constraint, general constraint, accepting the normal. Yes, it is true. And is fourth general constraint accepting the fourth attribute value in the xi. Yes, it is accepting, true, logically. And then fifth constraint is accepting the warm or not. Yes, it is accepting, true. Yes. Fifth constraint accepting, sixth constraint accepting the same or not. Yes, it is accepting, so it is true. Now attributes are over. Now you look at that logically, and true and true and true and true and true will give you the true. So true means here it is equivalent to the yes. So hypothesis of g0 is provide you the yes. And c of x1 also here yes. So both are equal. The rule is here h of x1 should be equivalent to c of x1. Okay, so now this is with respect to x1, which is matching. So this hypothesis is consistent, no need to remove, but we have to label it as a new hypothesis g1 with respect to training example x1. Then if it is over, we have to check the second step. The second step is moving into the specific boundary. We have to check all the constraint in the s0. So now when we are checking the s0 here, we have to match this. So null constraint is mapping with the sunny or not. No, it is not mapping. If it is not matching, then what we have to do, we have to apply this one. So more specific, null will be replaced by the specific value in the x1. So this is the specific value in the x1, the null should be replaced by the sunny. So this, from the s0 we are going to define s1 by removing this each and every constraint from the specific hypothesis by adding minimal generalization. Minimal generalization is this rule. So null is replaced by the specific value. Second null is compared with the warm, so it is not accepting, so this is replaced by the warm. So like that, the sixth null is comparing with the same. No, it is not accepting. So what we have to do, so we have to make it into, we have to replace that by same. So now, so here again we have to compare this. Sunny is matching with the sunny, so this one is matching with this one, true. And this is matching with this one, so true. And this one is matching with this one, yes, true. And this one is matching with this one. So like that, if all are matching, then all will be a true, so it is giving you a true. So now the h of s1, okay, that with respect to x1 equal to c of x1, so both are equal. So here also true, here also true. Then now this hypothesis is consistent with respect to x1, that is the d1, right? So now you look at that, the hypothesis g1 is more general than the hypothesis we found in the specific boundary. So here you look at that, this hypothesis g1 is more general than hypothesis S1 we found in the specific boundary. Now we have to check, is there any other hypothesis available in the? Yes, you look here we are having only one hypothesis, there is no other hypothesis, so this step is not valid as of now. Then we have to proceed to the next iteration by checking the example number 2, is it positive or negative. So the second example here, it is a positive, so since it is a positive, we have to go with this true block of the if statement. So in the true block of if statements, we have to start from the general boundary, we have to check the consistency, we have to compare. So now as of now we have only the G1, so from the G1 we are going to define new hypothesis G2, right, with respect to the sample number x2. So now we are checking, question symbol will accept Sunny, yes it is accepting, no need to replace. Okay, so then this is also accepting, yes no need to replace, this is also accepting, no need to replace, accepting, so this is accepting, so all are accepting, so it is giving you the true as per given in the previous slide content. So now H of G1 is true and C of x2 also true, C of x2 also true, so here H of G1 is with respect to x2. Okay, so now both are true, so it is a consistent. So now this new hypothesis is labeled as a G2, right? So this is labeled as a G2. Now the second step is we have to move into the specific boundary capital S. So in the specific boundary capital S, we have the S1, we have to compare with the given training example S2 x2. So here x2 is there, so now we will compare with the Sunny, yes it is matching. Then we are comparing with this one, so this is true and this is also true, right? And here you look at that high, which is a normal, so it is not matching. If it is not matching, what is the value here? The specific value it is available here, it has to be replaced by this question symbol constraint. So next general constraint is question symbol for the specific value constraint, so this is replaced by question symbol, and then strong is compared with here, yes it is matching, then it is true. So here question after replacing the question symbol, it will become true, then it is a warm, so it is also warm, so question symbol accepting true, so same here also same, so it is also accepting. So after replacing the question symbol, the H of S1 with respect to x2 becomes consistent because it is equivalent to the C of x2 yes. So now this is the consistent hypothesis. Now you look at that, the so some member, this is the member in the general boundary, this is more general than the new hypothesis S2. So S2 is now we found in this place, so by replacing the question symbol, this one, okay, we found the S2. So S2 is here G2 more general than S2, this step. Then we have to check, is there any other hypothesis available in the S? No, this is only one hypothesis available in the S2, so this step is not valid as of now. So now we have to check any other example available in the next iteration. So third example is available in our data set. So now we have to check the third example is yes or no. So third example is here the negative example. So negative example is to be checked with the specific boundary yes. Here S2 is already available, so from the S2 we are checking, so this is the S2 already which is available in the previous step. So Sunny is compared with the third example rainy, right? So it is not matching, so it is inconsistent. So if it is a negative example, we have to start the else block in the if statement. So here it is not matching, so then it is a false, then here it is a cold, it is also not matching, this is also false, right? So if it is if it is inconsistent, then we have to check, right, what is the hypothesis of x3. So now high, here it is accepting, so it will be a true, then here it is a strong, here it is a strong, it is a true, then it is a warm, here it is a warm, it is a true, change, here it is a same, it is not accepting, so it is a false. So false and anything, it will give you logically, and operation will be false. So false means it is equivalent to the no. So h of s3 with respect to x3 is equivalent to here c of x3. So it is a consistent hypothesis. So now s2 becomes s3. So no need to change anything in the new hypothesis s3. So same s2 is assigned as a s3 with respect to x3 sample. Now it is over. Now we come to the next step. The next step is here each hypothesis in the general boundary we have to check is it consistent or not consistent. Now you look at that, the question symbol is compared with the uh, first constraint in the x3 rainy. So is it accepting? Yes, it is accepting, true. And here cold, yes, it is also accepting, true. And high, yes, it is also accepting, true. And strong, yes, it is also accepting, true. And here warm, it is also accepting, right, true, right. And here it is change, so this is also accepting, true. So all are true will give you the true, which is equivalent to the yes. So h of g3 g2, h of g2, right, equivalent to not equivalent to, so the c of x3, look at that, h of g2 is yes, but here c of x3 is no. Okay, this is no, right? So which is inconsistent. If it is inconsistent, then what to do? We have to remove that constraint from the g, this constraint, by adding minimal specialization. What is the minimal specialization rule here? The question symbol to be replaced by specific value given in the sample number x3. Okay, so that is the thing. You look at that now. Here when you are looking that, so x3 is the negative, so here we will take each and every constraint at each time. So here we are having the 6 constraints, so we will replace each time one constraint with respect to x3, it should give false. Okay, h of g3 new hypothesis with respect to replaced constraint value should give the false. So now we will consider 6 number of possibilities. By replacing one constraint at each time, we are having the 6 possibilities. So 6 hypotheses are possible. First we are checking the first constraint. So first constraint is rainy. So here when you are replacing this rainy by which value, you will get the false, because our c of x3 is false. So what we need, what we have to expect, h of h of x3 in the g3 hypothesis should give you the false. So remaining all constraints should have general constraints here. Then we are replacing only one constraint value. When you are replacing by rainy same value, you see the rainy and all question symbol. So here also rainy, here also rainy, so it is a true, then all question symbol will accept all the values. So true, again it will give you the true. So it is not equivalent to the c of x3. So to avoid this, to get no in this place, we have to change this first constraint value as sunny, which is opposite, okay, against to the rainy value. Why we are changing into the rain sunny? In the sense, here we are having only two values in the sky attribute. When you are applying the rainy for the constraint here, okay, in this place you will get true in the h of g3, but we need false, we need a false. So to get the false, here we are replacing the first constraint in the hypothesis g3. Here we are applying the sunny. Then you look at that, now when you are applying this, sunny is matching with the first attribute, so it is a false. Then and question symbol, it will give you accepting the cold, yes, it is a true. Like that all question symbol is giving a true, so etc. Here you will get the true. sorry, false. Okay, because false is logically and with a true value, we are getting the false. So this false equivalent to the C of x3 false. So now this hypothesis is consistent. Then we are going with the second value. So here we are having here all our question symbols, but I want to replace the question symbol with the specific value. When you are replacing by x3 value here cold, but when you are supplying the cold here, then you will get only true. So against, we have to check until x3. Okay, so now we are in the x3 only, so we have to check until x3. So now the what is the next value? So here we are having the, for warm is the value against to the cold. So another value for the cold, that we are having the warm, so we are applying the warm here. Then remaining all are keep it same as given in the G2. So now when you are taking the this one, you compare with the x3. So here question symbol will give you true with respect to rainy, and warm here cold. So it is not accepting that, that means not matching. Then it is it matching? No, false. Then all are matching with the all values, because it will accept all the values, so it is true. So logically and with false with any value will give you the false. So now the h of g3 with respect to this one is also false, c of x3 also false. So both are equal, so it is a consistent hypothesis. Then you check the third value. So third value here we are having the high. So until the three examples only we have to see that. So when you are using the high, then you will here, if you substitute the high for the constraint 3, right? So again you look at that, high is matching with the high, so we will get again true. So if it is true, here it is a no, it is inconsistent. What we need here, we need the no. Okay, we need no. For no, you have to check the another value for the high, alternative value for the high. So what is the alternative value for the high? So in this one we are having the normal, so we are giving the normal in the third constraint. Then remaining we are keeping as a same question symbols here. So now as per this, we will get, look at that, so check this. So all constraints will give you the true here, but this one will give you the false. So false logically and with any true value will give you the false. So like this you check with the fourth constraint. Here fourth constraint is strong, so we are checking with the value here in the general constraint. So general constraint here fourth value is question symbol which is replacing with the strong. So we have to check, is there any other value available until three values, three examples? No, there is no alternative value, so we cannot replace this, so we are using the strong only. Then remaining constraints are same, so you look at that, now it is giving the true. Okay, so strong is matching with the strong, so it is all are true. This is also true, true will give you true. So here it is a true, but c of x3 is no, so it is inconsistent. Why we are unable to replace with another value? Because it is not having any other value in that attribute. Then fifth constraint, here it is a warm. You have to check, is there any other value until only the x3. Still we didn't go to this one, only it is in the third iteration x3. So we should not consider this example as of now. So which is also giving you a true, it is accepting this one, right? So it is also inconsistent, d2. This is no, but this is yes. Okay, then sixth constraint, when you are replacing with the question symbol, the here we are having the same, the you look at that, here we are having the change, we have to check until x3. So until x3 we are having another value same. So when you are substituting the same in the hypothesis, you will get the false value, because it is not same as a change. Okay, similar to the change, so it is false. Then these are all true, then true and with the false you will get the false. So now we got six hypotheses. Hypothesis 1, right? Hypothesis 2, hypothesis 3, hypothesis 4, 5, 6. In this 6 hypothesis, these two are inconsistent. So we got 4 hypotheses. Now we have to check with all the x1, x2, x3, because what is the definition? The hypothesis should satisfy all the xi with the c of xi with respect to these iterations. Three iterations done, so three iterations, three examples we have done. So we have to check with all the three examples. So we got now four hypotheses: one, two, three, four consistent hypotheses. These two are inconsistent hypotheses. Now you check this with the training examples. This is the hypothesis 1. So Sunny is accepting the rainy. No, it is a false. So it is a false. Then all are accepting. So all are true. So false and true, you will give you the false. So this hypothesis give you the hypothesis this G3, hypothesis 1 of G3 with respect to X3 equal to, here also no. Here also no means false. Okay, C of x3, so it is consistent. Like this, when you are checking, all will match. For example, warm, so here it is a cold. Okay, so it will give you the false value. So here this also will give you no, this will also no, so it will give you the consistent hypothesis. Here it is same, here it is a change, so it will give false. So false ANDed with logically and true, then it will give false. So here also false, here also no, so it will consistent. But you look at that, this one, here it is a question mark, so it will accept the rainy. So here it is a question mark, it will accept the rainy. Here it is a normal, right? Here it is a high. Okay, so it is accepting this one. What about x1, x2, x3? So you look at that, we have to check all the examples x1, x2, x3, right? So Sunny, it is matching. You look at that, it is matching, so all are true, right? Here also true, here also true. But the third example, it is rainy, it will give you the false. Okay, it will give you the false for the x3. So here it is also false, so it is satisfying. But the fourth hypothesis, this one, when you are checking the x1, here it is a normal, so it will give you the true. Okay, logically true with all the true, so you will give the yes. So this hypothesis of x1 also yes, so it is okay. Now we check with the second one. So second one, it is a high, but it is a normal, so it is a inconsistent. So this hypothesis is inconsistent with respect to sample number x2, so we have to remove this. So we have to remove this hypothesis. Finally we got three consistent hypotheses in the place of G3. Okay, now this is over. We have to move into the next sample x4. So now in the x4, we have to check, is it positive example? Yes, it is a positive example. Then we have to check the hypothesis is consistent or inconsistent. Then from this, uh, uh, we have to check two hypotheses are there. So it is yeah, sorry, it is from here G3. So it is accepting values. Yes, it is true. So we are having this hypothesis into here. And this one we are checking Sunny, yes, accepting. Warm, yes, it is accepting. Then it is also accepting all the values, so all the values are accepting. So this is also having as a new hypothesis G4. Then like that, third hypothesis here, all are question symbol until 5. So all 5 constraints are accepting. Here it is a same, here it is a change, so it is false. So false and with true will give you the false. So here it is a yes. So false and yes both are not matching, so it is a inconsistent hypothesis, so we have to ignore this. So G4 is having now only two hypotheses. So this is over. Now move into the specific boundary. In the specific boundary, we have to check, is it matching or not. So now Sunny, yes, it is matching. Warm, it is matching. Here high, question symbol, it is matching. Strong, here also strong, matching. Warm, but it is a cool, so we have to replace this by question symbol. And here it is a same, it is a change, so we have to replace this question symbol. So now it is satisfying the x3 by it is also true, it is also true, so it is a consistent. Now we got finally three hypotheses with respect to the sample number, yeah, x4. From the x1, x2, x3, we got four number of hypotheses. All hypotheses will satisfy this all four examples. Right now, since we are having the three hypotheses in the different boundaries, you look at that s4 boundary and g4 boundary. Okay, since we are having more I mean, here one hypothesis, here two hypotheses in the different boundaries, so we have to get different possible combinations by comparing these two boundary hypotheses. So now we will have here three specific values, three general values, so we have to compare. So sunny is sunny, so it is matching. So warm, here it is there. So now what we have to do, we will replace this question symbol with warm for different combinations. So sunny, then warm, then we will have same, all are same. Okay, only one constraint we are replacing. So then next one, here we will have the sunny as, we will have the warm as it is. Okay, and we will have the strong, otherwise we can have, we will not have the warm. So here sunny, here same question symbol. All right, just we will use the strong, we will use the strong, then question symbol. So sunny, three question symbol and strong. So like that, then you can use, you can replace the sunny and we can use the warm. So here now we can use, we can replace this sunny here. Okay, so here we can replace the sunny, sunny will be a question mark, then we will have the warm. Okay, warm from this. Okay, from this. Okay, sunny we will have as it is, right? Warm, then question symbol, right? Then it is a strong, so strong will be replacing this fourth constraint. So here we will have the strong. So then this two constraints we will have as it is, so we will have like this. So now we got the third hypothesis. Then we will have one more hypothesis by replacing this, replacing this sunny. Okay, so we will have sunny, so this one in this place. Then already warm is there, we cannot replace that. Then question symbol, question symbol, question symbol and question symbol, but this hypothesis is already existing when we are comparing this one. So here we can remove the duplicate hypothesis. Okay, so finally you will get here non-minimal hypothesis, non-minimal generalized hypothesis, non-minimal specialized hypothesis, three hypothesis. Here specific hypothesis 1, general hypothesis 2, totally we are having the 6 hypotheses in the version space of given data set D. Thanks for watching.